Let's start by clicking this button in a web browser. Instantly, a real lamp on a desk turns on. A digital command just manipulated the physical world. Today, we are going to build a complete smart home automation system from scratch. You will connect physical hardware to a custom, Java-based web dashboard. You will need an ESP8266 microcontroller, a DHT11 temperature sensor, and a relay module. For the software, we will use the Arduino IDE to program the board and the Java development kit to build the server. By the end of this, you will have moved past basic DIY electronics and constructed a full-stack software architecture that connects sensors and switches directly to a web interface. Our first step is the physical wiring. We are using an ESP8266 microcontroller and a DHT11 sensor, the blue component you see on the breadboard. Route the VCC power pins from the sensor and relay to the microcontroller and connect the ground pins together. Next, we add data connections. Wire the DHT11 sensor to digital pin D2 and the relay to pin D3. Before proceeding, a strict warning: do not test your relay with high-voltage AC appliances right now. Validate your setup using a low-voltage circuit, like an LED, to ensure everything works safely. The physical circuit is complete, but right now, this hardware is completely isolated. To make it a smart device, we need a communication protocol to send data to the web. We are going to use the MQTT protocol. This is a lightweight messaging protocol designed specifically for Internet of Things devices to talk over a network. Think of MQTT as a postal system. A publisher sends data labeled with a topic to a central hub called a broker. The broker looks for any subscriber listening for that topic and delivers the message. To set this up, go online and configure a free cloud-based broker like HiveMQ. Once registered, they will give you a specific broker URL and a port number. Keep those handy. This cloud broker is the central nervous system of your smart home. Every sensor reading and every button press will route through this exact URL. Now it's time to open your Arduino IDE. Write the setup code to connect the ESP8266 to your local Wi-Fi network and log in to the HiveMQ broker using your URL and port. In your main loop, create a code block that reads the temperature from the DHT11 sensor on pin D2. Instruct the board to publish that reading out to the broker under the topic Home/Temperature. Next, you need the board to listen for instructions. Write a command that subscribes the ESP8266 to the topic Home/Relay. When it receives an on or off message on that topic, it will trigger pin D3 to open or close the relay. A quick programming rule: avoid using blocking code, like the standard delay function. Pausing the processor stops it from communicating with the broker, which will cause your MQTT client to time out and disconnect. Upload the code and open your serial monitor. If you see connected to Wi-Fi and published 24 degrees Celsius, your hardware is successfully sending live data to the cloud. Now we build the server. Initialize a new Java Spring Boot application. In your pom.xml file, add the Eclipse Paho MQTT dependency. This gives Java the ability to speak the MQTT protocol. Create a Java service class. Inside, write the code to establish a connection to the exact same HiveMQ broker URL you used for the hardware. Add a method that subscribes to the Home/Temperature topic. Whenever the ESP8266 publishes a new reading, this Java method catches it and updates the backend variables in real time. To handle controls, create a REST endpoint. When you trigger this URL from a web browser, Java will publish the text string on or off directly to the Home/Relay topic. This Java backend acts as your translation layer. It converts standard web HTTP requests from a browser into the lightweight MQTT instructions that your hardware understands. To build the user interface, we'll use ThymeLeaf. It's a server-side Java template engine that lets us dynamically generate an HTML dashboard and feed it live data. In your HTML file, code a visual gauge component. Use ThymeLeaf tags to pull the live temperature variable from your Java backend so the gauge updates automatically as the room gets warmer or colder. Below the gauge, add an HTML toggle button. Map this button's action directly to your Java REST endpoint, so clicking it sends the command to trigger the relay. You now have a complete web dashboard. It turns raw environmental data into a readable display, giving you actionable control over the physical hardware. It is time to test the entire system. run your Spring Boot application and open your browser to localhost 8080. You should see your live dashboard loading the current temperature. Click the on-screen toggle button. The request hits Java, the MQTT command travels to the cloud, the hardware reads it, and the lamp clicks on. You have successfully built a full-stack IoT architecture from scratch, managing everything from low-level physical pins to a cloud-based message broker. Now that you have the foundation, you can expand the project. Try adding a PIR motion sensor to automate the lights, or a GPS module to log location data. You have established the core template for connecting any physical input to a centralized Java application.